Greetings and welcome to our session on creating FHIR implementation guides using FHIR shorthand, also known as FSH. My name is Mark Kramer, and I want to acknowledge my co-author and the co-inventor of FHIR shorthand, Chris Moesel. Chris and I work for a nonprofit organization called FHIR Corporation that works in the public interest in the US on problems of national importance. FHIR has been involved with healthcare and HL7 for more than a dozen years. In addition to FHIR shorthand, we've been major contributors to CQL, the clinical quality language, many IGs, and currently the Codex FHIR accelerator. So let me start by looking at what is FHIR shorthand. I like to think about FHIR shorthand in terms of this XKCD cartoon. You ask for a sandwich and someone else makes it. You don't even have to know how to make the sandwich or where to find the mustard. That's handled for you. So it's okay to be lazy when someone else is doing the work. But to be more precise, you're not making sandwiches. Your requests in this case are statements in the FSH language, and Sushi, the FSH compiler, carries out those commands. The sandwich, in this case, consists of structure definitions, extensions, value sets, examples, and more. So FSH is powerful because simple commands create complex artifacts. There are only about a dozen different types of commands. They're intuitive, mostly self-explanatory. In fact, I'll be introducing the FSH language today without bothering to explain very much of it. There are references that you can consult for those details. So what are the advantages of FHIR shorthand? First of all, it's short, it's concise and understandable. You can really see in a nutshell what's going on and what the intent is behind the IG. Second of all, it's all text. This has several major advantages. Foremost, you can make very rapid changes via text operations like search and replace. You can also use your favorite integrated development environment or IDE to speed up development. Also, because FSH is text, you can use source code control to collaborate and track changes. Fourth, when you run Sushi, the compiler, it automatically provides error checking and applies best practices. So there may be several ways to accomplish something in FHIR, but Sushi will choose the best way to do it. Fifth, Sushi and all the other tools around FHIR shorthand are all open source and free to use. The language itself is a balloted HL7 normative standard, so you can have confidence in the stability and the continuity of FHIR shorthand. Seventh, the language, the IG publisher recognizes FSH files and knows what to do with them, so it's built into the IG publisher. And finally, you can take any existing IG and turn it into a FHIR shorthand project using a tool we call GoFSH. So just to conclude this short background, we introduced this tool for the first time in 2020, and the number of projects using FSH has risen considerably. We've been able to track about 300 projects that are currently using FHIR shorthand. We've got a very healthy user community with about 400 chat subscribers in Zulip, and there have been in total more than 100,000 downloads of Sushi. So clearly FSH has hit the spot for the FHIR community. So let's dive right in and learn to FSH. So to take a step back now, the overview of the flow of using FHIR shorthand goes something like this. To get started, you'll install the FHIR publisher, Sushi, and your favorite text editor or IDE. We like to use VS Code, Visual Studio Code, because we have a custom add-on that formats FSH language for you. You then create a project, a new project, and start writing some FHIR shorthand. Along the way, you'll use Sushi to create FHIR artifacts and verify your work. And at some point, you'll add narrative text. Then you'll run the IG publisher to produce a draft IG. And of course, you'll be iterating these steps. And when you're satisfied with the results, you're done. So for the purposes of today's demonstration, I've already installed Sushi in the VS Code editor. So let's start at step 2, creating a new FISH project. So to do this, you open a command window and you invoke Sushi init. It'll ask you for several different facts about your IG, the name, the ID, the canonical, and the publisher, and the publisher's URL. So simply, you just choose these, you enter them, and it will run and set up your project. Okay, so you'll see a couple of errors here. This is because I'm behind a firewall and it is unable to download the publisher scripts, but I've already done that separately. So that's actually all you need to do to get started. Sorry about that. And what happens is it creates a directory structure, which you see here. So under the name of the IG, you'll see a directory structure that is very much like the directory structure that's required by the IG publisher, except there's a folder under the input, which is named FISH, FSH. And in there, we've got a sample file, patient.fish. That's a FISH file that that contains FISH language. The other file that's there right at the bottom is sushiconfig.yaml, and that contains some very important configuration parameters for using Sushi. So let's take a look at Sushi config first of all. So here I've loaded the whole entire directory structure into Visual Studio Code, and I just wanted to point out the extension, the FHIR shorthand extension. It not only colorizes the text for you, it has some functions like snippets, which allow you to save some typing. It has autocomplete features. It allows you to navigate easily through a go-to definition function. You can open the FHIR documentation directly, and you can run Sushi from inside the editor. So I'm not going to go into too much detail about those functions, but you'll see some of those features, especially the code colorization, as we continue. So I've opened up the Sushi config file, which is written in YAML. And the key thing that we want to do here is add a dependency on the Canadian baseline IG. So that's hl7.FHIR.ca.baseline. And we'll use the latest version 1.1.3. So that's very important because we're going to base some of the profiles on the profiles in the Canada baseline. So we're going to use an example today that we created. It's not very realistic, but it does demonstrate some of the features that you'll be using when you create, when you use FHIR shorthand. And the first one is an observation profile that represents ease of respiration. It's going to be based on the Canada General Observation Profile. And it has a required category of exam, which comes from the code system that you see. And it has a code identifying the observation from SNOMED CT. So let's open up a file, a new file. We'll open up the patient.fish file, which, as I said, is just a sample. Delete the text in there, rename the file. Since this has to do with respiration, we'll rename it respiration.fish, and then we'll start creating the fish directly in this file. So to do that and to make it a little easier, let's zoom in on the content on the right side. Okay, so here we are in respiration.fish. So the first kind of statement is actually kind of trivial, which is a comment. So I like to comment my fish code, and to do that, you can use a double slash, similar to Java. Now, every fish item consists of 3 parts. The first part is a declaration. This is what you want to create. In this case, we want to create a profile, ease of respiration. So we simply, the declaration is simply the word profile with a colon and the name of the profile you'd like to create. The second ingredient in any fish item are a set of keywords. In this case, there's 3. We need to, the key one, I think, keyword is the parent. So which resource or profile does the ease of respiration profile inherit from? In this case, it's the observation profile, which is actually the name of the Canada General Observation. The other keywords are ID, title, and description, which you can read yourself. The third part, which is really the most critical, are a set of rules. These are your commands that I mentioned. We call them rules. And the rules will do everything in the profile that you'd like to override. In other words, it is basically the diff between the base profile and the profile you're trying to create. So the first rule that we're going to have, that we're going to introduce, is an assignment that takes the code of this observation and sets it to that SNOMED code 248546008. Now, the form of this code is code system and then the hash sign and then the code. And you'll notice I'm using SCT for SNOMED, which is not the canonical name, but I'm lazy and I don't like to type. So I actually introduce at the top here an alias for that longer string. And SCT then can be used anywhere I would like to type that longer string. So that's the code system. The second rule is to set the category. So there's a required category, and that means that the cardinality is going to have a lower bound of 1. We also want to make the category must support. So we use 1 ... star to set the cardinality. You're probably familiar with that, and MS to set the must support flag. And the category has to contain a certain value. In this case, it is exam. And I'm going to use some magic here, which automatically creates that category slice. And I'll explain this magic a little bit later when we talk about rule sets. But you can think about this as kind of a macro function, which creates a slice called exam category with the code exam from the code system CAT and a minimum cardinality of 1. Well, what's CAT? Again, I'm a lazy typist, so I'm going to define an alias for a much longer code system URL, which will pay off if I get to use that, again and again. And it adds to the readability of the file. And finally, the value is going to come from a value set. So we want to first restrict the value to a codable concept and then bind it to a value set. So to restrict it to the codable concept, I'll use what's called an only rule and say it can only be a codable concept. And then we'll bind it using a from rule and say that value must come from the ease of respiration value set, and it will be a required binding. Of course, the ease of respiration value set doesn't yet exist, so the next thing we'll have to do is create that value set. So let's go on to the ease of respiration value set. These are 3 codes taken again from SNOMED CT, so we'll reuse that alias. And it follows a very similar pattern. So first of all, we're going to set the declaration, which in this case is value set, and the name we've already chosen, it's ease of respiration value set. Then the keywords for a value set, there's no parent. It just has an ID, a title, and a description. And then the rules are really, really simple in this case. They're simply the codes. So those 3 codes, and we're finished defining that value set. I forgot one thing, which is that you have to define, you have to set the copyright to make, otherwise the publisher will complain. So actually I've set that into a rule which simply substitutes the copyright, and you can use this shorter version of the copyright anywhere you create a SNOMED-based value set. So here's the rule set that's behind that copyright, and it really is quite simple. The declaration is rule set with the name SNOMED copyright, and all you need to do is define the copyright, and I also defined the experimental value, which is now required. So if this ever changes and the copyright statement changes, you can change it in one place and it'll automatically, be included wherever you have that copyright statement, which in some of the IGs you may have, 20 or 30 times. All right, so the next part of this example is to create some instances. So our patient is named Colin Robinson, a male born in 1965, and the patient must conform to the Canada Baseline Patient Profile. The second instance is a observation which fits the ease of respiration profile, which we just created, and expresses that Colin is experiencing labored breathing. Before we dive into that, I'd like to just explain one thing, and that's how paths are expressed in FHIR shorthand. It's actually very simple. A top-level element is just referred to by its name, not including the resource name. A second level or nested element is expressed with a dot between the top level and the second level. And likewise for a third level element like name.period.start. So you simply append as deep as you need to go with periods. Now, an alternate way to do that is to use indentation. In this case, the indented row is implicitly dotted with the rule that is indented more to the left. So name dot, the second row there it is really the same as name dot given, and the last row is equivalent to name.period.start, and that's inferred by Sushi from the indentation. So now we can start with those instances. So we'll go and continue to add to the respiration file. So let's start with that. So the keyword for the declaration of an instance is instance, and in this case, the instance, we're going to name it Colin Robinson. A important keyword is instance of, and this points out which profile the instance is supposed to comply with. This can be a resource or a profile name. We also have a title, a description, and now we'll start populating the instance with some rules. So we'll use the indentation. So the first given name is Colin, and you'll notice the zero-based indexing of the array. The family name is Robinson. The gender is male, and the birth date is, let's give him May 12th, 1965. And that's all that's needed for this instance. So now let's do the respiration assessment. That's a instance of the ease of respiration profile. We have a title, we have a description, and we'll set the subject of this observation to reference Colin Robinson. So the name up here, Colin Robinson, is the name that's down here in the reference. And reference is a reserved word within FHIR shorthand. Next, we'll set the value, which indicates that Colin is suffering from labored breathing. So this is just the value codable concept to this SNOMED code. And you'll notice I'm using the alias once again, so I don't need to repeat the alias definition here. I can use the SCT as many times as I like within this project. And finally, the effective date of that observation and the status, which is final. So now we've created those two instances. All right, so now we're ready to run Sushi, and that's actually quite simple. We'll open a command window. We'll navigate to the top level of the project that we created and invoke the Sushi command by typing Sushi with a dot that indicates it's executing on the current directory. All right, so we're back in the command window and we'll change the directory to where we have our project and invoke Sushi. And when you do this, Sushi will start to run and we'll give you some messages as it goes along. And it'll quickly reach completion. In this case, you see the results box, which shows that we've created one profile, one value set, and 2 instances. And we're also rewarded with a pun. You are dolphinately doing great. So what actually happened is that it created a new directory within our project structure. It's fish generated, and you can see that right here. And inside that, we have another subdirectory called resources. And inside the resources subdirectory, we have 4 profiles or FHIR artifacts, and in addition, it has an implementation guide resource, which is needed when you run the IG publisher. So this is the structure that's anticipated by the IG publisher. All right, so let's now go to the next step, which is to create a device profile. So we're going to switch gears a bit. So we're going to create a profile called a maintained device, with 2 extensions. One extension records the total device hours used, and the other extension records a series of maintenance events. And those maintenance events are described by 3 elements. One is the date performed. The second is the current device hours at the time the maintenance was performed, and the third, the performer. So let's start with the first one. So we'll open up a new file, create a new file, device.fish. And in fact, you can create as many fish files as you want, and you can put any definitions, fish definitions, in any file, because when Sushi runs, it puts all these definitions in one big bucket, and the file boundaries become irrelevant. So in the device.fish, we'll define an extension. The declaration word is extension for total device hours. And it's got an ID, it's got a title, it's got a description. So what we want to do with this is just give it a value that's a decimal number. So we will use an only rule to set the value type. And we'll also use another macro to a rule set to set the extension context, which says that this extension is only usable on the device resource. Okay, so that's a simple extension with a value. Now, complex extensions are a little bit more complex. This is an extension with extensions. At the top level of the extension, there is no value. So what we want to do is populate the extension array of an extension. And if you notice in the definition of extension, it has an extension array that's inherited from element, which is its parent. So to populate this extension array, we need a new rule type. And this is a contains rule. Essentially, we populate that extension array by saying it contains some extension, we'll give it a name, with some cardinality. So let's see how that plays out in FHIR shorthand. So let's continue with this device file, and we'll create another extension which represents the maintenance event. And it's got an ID, it's got a title, and it's got a description. Now, this contains rule is going to contain three extensions: the date performed, the current device hours, and the performer. And you'll notice that the cardinalities are different. We'll require the date performed. We'll only allow one current device hours and maybe more than one performer. Now that puts those elements within the extension array, but we need to also say what data types they will contain. So to do that, we'll say that the extension, date performed extension, has a value that's only a date, that the current device hours value is only a decimal data type, and the performer will be a string. So now we've defined that maintenance event, and I think we'll add also the extension context, which will limit it to the device resource. Now we're going to add the extensions to the device itself. So this is a top-level extension element, and again we'll use the contains rule in a slightly different form because we'll have to refer to those freestanding extensions we've just created and give those extensions a local name. So let's see what that looks like. So we'll begin by creating another profile called maintained device. It will be based on the Canada baseline device profile, whose name is device profile medical. And we'll give it an ID and a title and a description. Now the rules are going to start with a contains rule saying that we have populated the extension array with our predefined standalone extension total device hours. We'll give it a local name, total device hours with a small t, and allow only one of those. So 0, 1 cardinality, and we'll make that a must support. And then we'll also add the maintenance event to that same extension, and we'll give it a local name, but we'll make this one 0 star, so we can have more than one maintenance event, and also make that one must support. So you'll see that this rule has the name of the extension we defined, as well as local names. All right, so now that we've defined that, let's go ahead and create a instance of a maintained device. Let's pretend that Colin needs a CPAP device, and the code for that is here. And this CPAP device, undergoes periodic maintenance, so it conforms to the maintained device profile. And let's say that we've maintained it at 1200 hours by Laszlo Cravensworth, and we're going to assign that device to Colin Robinson. So let's go back to the device FHIR file, and we'll start defining that instance. So it's an instance, let's call it Colin CPAP. What is it an instance of? It's an instance of our profile maintained device. And we'll give it a title, a description, and the type is that code for the home continuous positive airway pressure. Again, it's a SNOMED code. And the element in device is called type rather than code. And we'll assign it to a patient. The patient is a reference to Colin Robinson, who already exists. We've created that before. And we will populate the extension, the total device hours extension, with 1200 hours. And populate the maintenance event with the date performed of October 26, 2022. And you notice this has two levels. So the maintenance event extension has an extension date performed, and its value is this date. Likewise, we'll populate the current device hours at 1200, and the performer of that maintenance event is our friend Laszlo. So that concludes the creation of this instance. So let's do something else. Let's create a capability statement for this IG. And this capability statement will involve just putting some support requirements around observation. Obviously, we have other things. We have another profile. We could put some capabilities around, attach some capabilities to, but we'll only do the observation for brevity. So here are the specifications. It'll support the ease of respiration profile. It shall support the create and search interactions. It may support the update interaction. It shall support the search by subject and by code, and should support a search by time. Now, for this one, capability statements are actually a little complicated, but fortunately there's some pre-built rule sets that you can find at fishschool.org. And if you just click through to Fish Online and then Fish Examples, you can find these rule sets. So what these rule sets do, and I've abbreviated them here, is that they have all the code that's necessary in Fish to support resources, support profiles, support interactions, and support search parameters. And what we haven't seen before is rule sets with parameters. So when you use the support resource rule set, for example, it takes two arguments, the resource and the expectation. And the expectation is going to be must or should or may. So that's the level of expectation. Similarly, for profiles, you give a profile name and its expectation, the interaction name and its expectation. And for search parameters, it's a little bit more complicated with 4 parameters: the name of the search parameter, its canonical, its type, and the level of expectation. So, this saves a lot of work, as you've seen before with rule sets. So let's build ourselves that capability statement. So here's the instance of the FishIG capability statement. It's an instance of a capability statement. It has a title, and it has a new keyword, which we haven't seen, usage, which indicates that this is not an example, but it's a conformance definition. So let's begin with a description. There's a number of attributes that you need to set in capability statements. This is for a server. Its status is draft. It has a date. It has a kind. It has a FHIR version. It has a format. And now we'll begin to see the rules. So we'll insert the rule sets for supporting resource observation. It shall support the observation resource. It shall support the ease of respiration profile. It shall support read for that for observation. It shall support search. It may support update. It shall support the search parameter on subject, as well as for the value, the concept, the value of concept, as well as the date of that observation. So that in fact completes the capability instance. And now we can begin to add some narrative content to our IG. So you'll notice in the project directory, there's a subfolder under input called page content. And inside that we already have given, when you did sushi init, we created a dummy file of Markdown called index.markdown, and that's the landing page for your IG. So we'll just put some content in that index file. So we'll just, in fact, copy some text that from Wikipedia on pulmonary function testing and fancy that up a little bit. And that's, I won't explain Markdown, but we're just going to populate that with an image or two and some Markdown text. So at this point, we're ready to run the IG publisher. So to do that, we just go to the command prompt again and run the gen once script. And the publisher will run sushi for you. And it'll generate a couple of directories after it runs. The fish generated has the FHIR artifacts, which are the result of running sushi, and an output directory, which has your actual IG. And to see the IG, you open the index.html file. There's also an input cache and temp and templates directory, which are generated during the run of the publisher. So let's go ahead and do that. All right, I think we're done. That was about 3 minutes we condensed into 20 seconds. And here's the resulting IG. It looks pretty respectable. This is a home page just from our Markdown, but the most interesting thing, I think, is if you go to the artifacts, you can see all the artifacts that we've created. The capability statement, the 2 profiles, the 2 extensions, the value set, and the example instances. So this is, let's drill down on the ease of respiration profile. Let's look at the differential, and you can see that we've set the category of exam category. We can go back to look at the maintain device, and of course we'll provide this so you can take a closer look. The maintain device has these 2 extensions, the total device hours and maintenance event. So let's drill down on the maintenance event, which is the interesting complex profile. You can see it has the 3 sub-extensions that we've defined, the date performed, the current device hours, and the performer. So that all looks good. And we can see the value set. I'm going through this quickly, but it has the 3 values that we defined. So all in all, it looks pretty complete. It's got the example instances. Here's the CPAP device that has its total device hours and the 1 maintenance event that we put in. And it's got the respiration assessment that says that Colin Robinson has suffering from labored breathing. So that's the IG. Okay, so there you have it. Just in recap, we've created an implementation guide in 45 minutes. It has 2 profiles, 2 extensions, 1 value set, 3 instances, and 1 rather complicated capability statement. The whole thing was done in 90 lines of fish, which works out to about 10 lines of fish per item. And we invite you to view the IG. You can see the link there. You can also go to GitHub and see the fish sources for this example. If you'd like to learn more, there are 2 sources I can recommend. One is fishschool.org, and the other is the formal specification of FHIR shorthand language, which is at hl7.org. So at this point, I would like to thank you for your attention, and I hope you've enjoyed the fish.